Alright, in this video I'm going to show you how to work with lists, or more accurately, generic lists in C#. So let's create a list. We use the new operator to initialize an instance of the list class. Note the angle brackets here in the IntelliSense. That indicates that list is a generic type. And also note that it's defined in system.collections.generic. If you don't have ReSharper, the IntelliSense you see is going to be different. I don't think you're going to see the namespace, which means you have to go on the top of the file and type using system.collections.generic. Once you import the namespace, then you can come here and create a list. You specify a type here. So let's say we would like to create a list of integers. That's it. We can initialize this list ahead of time using the object initialization syntax. So I'm going to supply 1, 2, 3, 4 here. Now we can add something to this list. So numbers.add. I would add another one here. So this is the difference between a list and an array. In an array, we don't have an add method. And once we create the array, the size of the array cannot be changed. But in a list, you can add as many objects as you would like. We can also use the addRange method to add more than one object to the list. So numbers.addRange. And note that in the IntelliSense here, we see I enumerable of int. What is the I enumerable? Well, first of all, whenever you see a type that is prefixed with I, that is an interface. I have covered interfaces in detail in the second part of this course. So for now, we want to keep things simple. I want to give you a quick tip here. Whenever you see I enumerable in the IntelliSense in C#, you can use an array or a list there. Once you understand interfaces in the second part of this course, then you will realize that that interface is implemented by different classes like the array or the list, which means whenever you see I enumerable, you can supply an instance of a class that implements I enumerable. Now, if all that sounds too complex, don't worry about it. Again, remember my tip, whenever you see I enumerable, you can use an array or a list. So let me create an array here. New int array. I'm going to specify the size of 3. And I can use the object initialization syntax to immediately initialize this array. 5, 6, 7. Now, it's very unlikely that you're going to write code like this in a real-world application. So don't be intimidated by this weird way of initializing a list. All I want to show you here is the number of possibilities when working with lists. You don't have to memorize anything. All I want you to take away here is an idea of what you can do with a list. So you can create a list like here. You can initialize it ahead of time. If you know the objects you want to store there, you can call the add method to add one object to a list, or you can call addRange to add another list or an array to the list. Now, once we have a list, we can iterate it using a forage loop. So for each var number in numbers, console.writeLine number. Let's run the application. So we got 1, 2, 3, 4, 1, 5, 6, 7. Now let's take a look at the index of method. So numbers.indexOf. This method has a few different overloads. The simplest one, which is the one that is currently highlighted, means you can pass an item of type integer here, and this method returns the index of that object in the list, if it exists. Otherwise, it returns -1. The second overload of this method takes another parameter called index, and that's the starting point. So you can say start your search from index 3. And the third overload of this method specifies the number of objects to include in the search. The first overload is what you would be using most of the time. So let's see what's the index of 1. I'm going to display it on the console. Let me add a label here. So index of 1. And I would like to have a console.writeLine here to separate it from our for each loop. So index of 1 is 0. But interestingly, we have two ones here. Here's the first one, and here's the second one. We have another method called last index of. Let's take a look at that one. So I'm going to duplicate this line and instead use last index of 1. Let's run the application. So last index of 1 is 4. So sometimes you may want to start your search from the beginning of the list. In that case, you use index of method. Sometimes you want to start your search from the end of the list. When in the real world does that happen? I can't really tell you now because it really depends on the algorithm you're designing. Now, let's take a look at another useful member of the list class, count. So, count numbers.count. So this is a property that returns the number of objects in the list. Let's run the application. So currently we have 8 objects in the list. Now let's take a look at the remove method. So numbers.remove. I'm going to remove 1 from the list. Now let's iterate the list again and look at the result after removing 1. So I'm going to copy this for each block and put that here. Now let's run the application. So note that the first one is gone, but we still have another one. What if you wanted to remove all the ones in this list? So one way to do that is to use the Forage Loop. So let's change this example to something like this. We iterate the list one object at a time. We check if number is 1, then we remove number. Once we do that, let's copy this for each loop again and put that here. Let's run the application. The application crashed. Why? We got an unhandled exception. Let me cancel here. This is an exception or an error that you may see from time to time when you are removing an object from a list inside a for each block. So look at the exception detail here. It's of type system.invalid operationexception. And the message says collection was modified. Enumeration operation may not execute. So what this means is in C# we are not allowed to modify our collection inside a for each loop. So inside this for each block, we have this numbers.remove, which is modifying the collection. So how can we change this program to get the desired result without that exception? We need to use a normal for loop. So something like for var I is 0. Run this as long as I is less than numbers.count, then plus plus, and we move this code here. Now here we need to change that to numbers of I, because we don't have a local variable like the for each called number, right? So we need to access the current element in the list using an index, numbers of I. Okay, let's run the application. There you go. So we removed both ones from the list. And one last method before we finish this lecture. So let's take a look at the clear method, numbers.clear. So this method removes all elements from the list. Now if we display count on the console, we're going to get 0. So I'm going to grab this line here and paste that here. So look, The last count is 0. So this was an introduction to the kind of things you can do with a list. I hope you enjoyed this lecture and thank you for watching.